Hey guys, how is everyone? In this video, we're going to take a look at a basic RIP configuration. So basic RIP. And we're going to take a look at version 1 and we're going to take a look at version 2. Okay, we'll go over a lot of the basic bullet points and things that I want to just cover in this video. And then we'll take a look at timers and RIPng, and we'll take a look at triggered updates and all that kind of fun stuff in separate videos. But here again, we just want to take a look at getting basic RIP up and running and taking a look at some of these different features and different things that we just have to make sure that are fresh in our minds. So a little bit of housekeeping here. Let's actually just draw out how we're going to configure our network. Let me pick, we'll pick red. We'll keep it red so it's bright. We are going to run a RIP configuration here between R2 and 4. This is going to be a version 2, and we're going to use unicast here. We're going to say unicast, and we're going to say only. So we want no multicast running between that link. We're going to use... Actually, you know what? Let's reverse this. So we'll use here, and we'll say this is going to be version 2. We're going to say version 2 down here, and this guy's going to be unicast only. We'll say unicast only, so no multicast. We're going to take the interface of R6 and the interface of R2, and we're actually going to have a RIP adjacency here as well. And the reason why we're going to do that is because we know that RIP version 1 and version 2 are going to have a hissy fit about the fact that router 6 and router 2 are essentially going to be sending each other updates on two different subnets. So if the mask doesn't match or the actual subnet doesn't match, we're going to have a problem with RIP. And there is a way around that, but again, this is how I'm going to demonstrate. Normally, most people don't jump a router like this in RIP. They normally just don't, have one router on one side of their network and have RIP, neighbor up with a router all the way on the other side. Normally, this is something most people in today's world do in BGP. But unfortunately, here I didn't set up a dial-up network, so this is just how I'm going to demonstrate that for you. Now we have a DMVPN running between router 3 and router 1 and 2. So I'm going to say DMVPN here. Okay, and we're using that to demonstrate our split horizon rule. That's essentially going to block routes from being sent out the same interface they're received. So when router 2 sends in these updates to router 1, we want router 1 to be able to send these updates back out to router 3. Essentially, the end goal here is that router 5 should be able to reach router 6, or at least have the routes in his routing table. Because we're going to jump over router 4, we may have a routing problem here on router 4, but we'll see what happens. We may not, but we'll tackle it when we get to it. And so that's how our network is set up. One minor note here that I want you guys to not ignore, but ignore. In other words, know that it's there, but ignore it. We are running OSPF on these physical links between R1, 2, and 3. Reason we're doing that is for the loopback zeros to be able to reach one another so that we can actually form our DMVPN tunnel. Okay, because the loopback zeros are essentially our destination. Now, what I'm going to do here, I have a packet capture that's currently running. So let me just stop it, and let me bring up my Wireshark here, and we're going to close this and just kind of restart it so that we have a fresh session going. Doing multiple RIP videos here today, so let me just restart this so we have a fresh session going. We'll go back to our CLI and let's get RIP going. So I'm going to say config T and say router RIP. At this point, I have RIP version 1 up and running, but the thing is that RIP will not actually activate until we type in a network statement. So when we get to router 4, when we do some redistribution with our connected routes, we're going to see that it actually won't activate until we hit the network statement. So what I want to do here is I'm going to say network, and I'm going to say 10.2.4.0. Now, one thing that really makes people crazy about RIP is normally in EIGRP or OSPF, you would go in and you would use the network statement to activate the routing process on whatever interface you entered here. If all the interfaces you wanted to run OSPF on were 10 interfaces, you might summarize them in your network statement, but the idea is that you wouldn't want to enable a process on any interface that you don't want to run RIP on. Well, RIP does not accommodate you. Do show run section RIP will reveal that our network statement is going to go back to its classful boundary. And what makes people crazy with this is that they go in and they run RIP version 2 and I'll do that in a minute. They go in and they run RIP version 2, and they say, why is my network statement still going to its classful boundary? It's always going to go to your classful boundary. It's never going, you're never going to be able to say 10 to 4, 2, or 0 or whatever. RIP version 1 will only support classful advertisements. In other words, when RIP version 1 advertises out any networks that we have on router 2, it's always going to essentially auto-summarize them to their classful boundary. Whereas in RIP version 2, you can turn that off. But the network statement is always going to be a classful network statement. So please don't get confused there. Now, what I'm going to do is I'm going to say do show IP protocol, and I just want to show, good, so let's say do debug IP rip. Now, this is generally the debug command that we're going to run in RIP, debug IP rip. That's the best we really have. Now, here under the show IP protocol, I can see a little bit more detailed information. I see all my timers, which I'll get into in another video, but the timer I am going to point out is the update timer. So by default, let's say turn this off now that we have our update. By default, our timer is going to be every 30 seconds. And in version 1, this is all we have. Whereas in version 2, we can support triggered updates in some situations and scenarios. So we have a 30-second interval timer here, or a 30-second update timer, I should say, in which we're going to send our full routing table. So at this point, the full RIB, all the networks that we essentially know about that we have, are going to go out to our neighbor. And it lets us know that, hey, the next update is due in 24 seconds. So if I said do show IP protocol again, and I come down, it says 26 seconds. If I do this again and come down, 22 seconds. I mean, you get the idea at this point, right? 19 seconds. The other thing about RIP is that you can tell by our update, if I go back up here, let's say do debug IP RIP. Let's see if we can get a few more updates. We may have to wait. I may have missed it. 26 seconds. So just reset. Sweet. Do on all. So this is exactly what I wanted to show. So RIP version 1, you can see that it's a broadcast update. So it says, hey, we're sending a version 1 update, and we're doing that to a broadcast address. So we're going to broadcast this update out to everything on this LAN segment here. So it's going to go out this interface to this LAN segment. It's going to go out this interface to this LAN segment. It's going to go out this interface to this LAN segment. RIP version 1 and version 2 with their network statements does not accommodate you in being able to dictate what interfaces you want to enable and disable based on your network statement. The only way for you to essentially stop RIP from sending updates out those interfaces would be to do a passive interface. Now, there's a couple ways I could do this. I could say passive interface default. And what that's going to do is that's actually going to passive interface everything. So at this point, I'm not sending any updates out anywhere, any interface, even though I have a network statement. However, what I can do is I can say no passive interface, and then I can say E01, which is this interface here that faces router 2. At this point, if I go back, let me turn the debug back on. If I say do show IP protocols here, and I scroll down, we have 18 seconds, so let me actually go down again and show you kind of a better output here. You can see that, okay, it says, hey, these guys are your passive interfaces. So essentially everything you've passived out except for, and there's our update. And you can see that our update only goes out the Ethernet 01 interface. And this is the only one that's enabled. And it lets us know exactly what we're doing on that interface. So it tells us, hey, you're going to send version 1 updates, but you can receive version 1 and version 2 updates. So if we essentially configured router 4 for RIP version 2, which is what we're going to do, we should see router 2 accept these with no problem. It also tells us whether we have triggered updates enabled. So we have a lot more information with regards to our RIP configuration in the show IP protocols. Now, let's head over to our packet capture real quick. I'm going to spend a little bit of time here just because I want to get this stuff out of the way. Now, we've said that RIP version 1 does not support VLSM, right? And what's the reason for that? Well, if we go down and we expand RIP here, and we go down and we say, let's see. Oh, we're not actually, let me go down here to one of these. Well, it doesn't look like it's complete. There we go. So now that packet wasn't for whatever, that may have been for some reason it didn't include the subnet information. So we scroll down to this one. This packet here contains the actual networks that we know about, or that router 2 knows about. So you can see it was router 2 10242 sent this broadcast packet, RIP version 1, and you can see it says, hey, UDP port 520. Here's our source and destination. But the reason why we don't support VLSM is because in the actual update, when we look at the IP address, when we look at the network that we're actually sending, it does not include an area for the subnet mask. It also doesn't include an area for the next hop, by the way. So in version 2, you're actually going to see an update field for the next hop, and you're also going to see a field for the subnet mask. That's how in RIP version 2 we are able to actually support VLSM, because then in RIP version 2 we have a field for that. And don't forget that the metric here is going to equal the hop count. So metric 1 is saying the hop count is 1. So let's head over to 4, and we're going to say config T, and I'm going to say router RIP. Now I'm going to configure this the way that I normally would configure it. I'm going to say version 2, no auto summary, and then I'm going to go ahead and enter my network statement. Now, you know, it's funny because once you know that no matter what you do, no matter what voodoo magic you do, this will always be a classful boundary. It's almost like the stress goes away, and you know that this one time you can be lazy and get away with it, and nobody's going to yell at you. It's actually pretty cool. Nobody's going to bark at you. So at this point, we see that we have RIP version 2 configured. We're going to do one last thing, and that's redistribute our connected routes. We have a few interfaces here that we want to be able to advertise, and mainly those interfaces are our 3 loopback addresses here that we're going to use to test reachability, that everything is working. So if I go down to RIP here, you can see, let's say do on all, you can see that on router 2, it says, hey, I received a version 2 update from this particular neighbor. And it lets us know, hey, I received these 4 new addresses here that essentially that I'm going to go ahead and add. And if I say do show IP RIP database, we can see a little bit more detail about them. So we can see, hey, this was essentially the neighbor. This is the via. So this is essentially our next hop. This is where we're going to go. This is who sent us the route. Here's our metric. It's going to be a hop count of 1. It lets us know the subnet. This is for 192.168.40. And then here is the VLSM information. Now, if I turn to auto summary back on, I, in theory, wouldn't see this. I would see a 4/8. So I would see this essentially twice for the most part. Now we have a problem over here on router 4, though. So let me say do debug IP RIP and say do show IP protocol and see when. So it's due in 8 seconds. Let's check do show IP protocol. Let's see when. So we have 18 seconds essentially to wait here. So let's see. That's sending. So this is router 4 sending his update. I'm going to tackle 2 things in one shot. I'm just waiting for that last message here to come up. Say do debug IP RIP. It may happen on router. There we go. Okay. So you can see here a few things, a few tidbits of information. Router 4, now running in RIP version 2, no longer sends that broadcast packet. It says, hey, I'm going to send a version 2 update, but I'm going to use the multicast address of 224.0.0.9. Still uses the same port, though. So if I scroll down here to the bottom of our packet capture, here's router 2 sending his version 1 update. Here's router 4 sending his version 2 update. Let me just close this down. You can still see that we're using the same port number. It's just multicast rather than broadcast. So now we're only sending it essentially where we want to send it, right? We still got to passive interface some things out, but we'll get to that. The one thing I want to show you, though, is that now the problem is that router 4 is saying, hey, I've ignored this version 1 update that I received from this guy, which is essentially router 2, because he's sending me an illegal version. Let's say do show IP protocols here, and let's see what RIP is actually allowed to get. Well, you can see, let's see, this is the interface here between 4 and 2 that we're receiving updates on. So if we check our Ethernet 01 interface, it says, hey, I can only send and receive version 2 updates. Now, there's a couple ways that I can fix this, okay? I can tell router 4 to receive version 1 updates, that's okay. I can tell router 2 to send version 2 updates. So what I can do, and it's essentially the same command, I can say interface 01, I can say IP RIP send, and then version, and then either version 1 or version 2. So at this point, I can say show IP protocols. And if I go down there, we can see that router router 1 is now going to say, hey, I'm going to send version 1 updates, right? That's not really the way you want to do it, though. I mean, really, the only reason you would do that is for some reason if you were not able to run RIP version 2. I mean, running RIP version 2 is the answer to the problem. This is really just a quick fix. So if I say do show run interface Ethernet 01, we really don't want to send different versions. I mean, you can, again, if for some reason you could not run version 2 on router 2, really old version of code, it just, against company policy, against your exam requirements, whatever it may be, you could tell router 4 to accept version 1, you could tell router 2 to send version. I mean, there's a lot of different ways that you could do this. Or you could say, I actually had this wrong. It should have been version 2, not version 1. So I would have said this. Do show IP protocols. And you can see that this actually changed to send version 2. So I actually had that dyslexia in action. If you guys ever watch my videos and I say something completely backwards, don't mind it, dyslexia. Do show run interface E01. So let's actually turn this off. And what we want to do is we actually want to go and we want to say router RIP, and we want to just say version 2 and no auto. At this point, if I go and say do debug IP RIP on router 4, we should see that with no problem, he's now going to receive these updates. Just check our interval. So we have 21 seconds left to wait. That's okay. So we sent an update. Again, to multicast. While we're waiting, let's go ahead and say passive interface default, and we'll say no passive Ethernet 01. So at this point, we have essentially, we're only sending updates out between these two devices. And you can see, now it lets us know, hey, I've received a version 2 update from router 2. All is well, no problems. And that's exactly what we want. So we're good to go here, okay? Let's go over to router 3 and router 5, and let's get these guys cranking. So router 3 is going to be an easy config. We're going to say router RIP version 2, no auto. We're going to say network 10.0.0.0, do show run section RIP, and we're done. One thing we are going to do is say passive interface. Actually, you know what? Let's leave this off for now. And let's turn the debug off. Do on all on router 2 and 4. Gotta hurry up. We're already 20 minutes in. I'm not even halfway done. Config T, router RIP, version 2, no auto. I am going to say passive interface default. I'm going to say redistribute connected. Actually, let's say no passive default. Okay. Now, you'll notice here that I've gone and I've typed a bunch of commands. So router RIP, version 2, no auto. I did type passive interface, then I took off passive interface, but I typed redistribute connected. Here's another thing that really makes people nuts. They'll say do show run section router RIP, and they get absolutely nada. And they say, well, what's going on? RIP won't activate until you use the network command. So you have to say network 10.0.0.0, do show run section RIP. Now RIP is actually going to activate. So you have to be careful there. You have to know that it's not going to activate until it sees the network command. A lot of people say, oh, it's got to be an iOS bug. I can't see my RIP configuration. There are rare occasions where iOS doesn't like the older syntax for some reason. It won't go and find it if you do something like show run section RIP. But most of the time, I see guys trying to get a unicast relationship working, and I'm going to show you the mistake that they always make in a minute, but it won't activate without the network statement. So let's just make sure that we have everything set up here. Let's say do show run section router RIP. Okay, let's say do show IP RIP database. We should have the loopback addresses over here from router 5. Do show IP route RIP. We're good to go. So I should be able to say do ping 192.168.5.1. No problems. All is well. Now remember though, we said unicast only. So let's say do debug IP RIP. We're going to do this on both devices. Do debug IP RIP. So we need to run unicast only. Now typically in OSPF and EIGRP, if we wanted to run unicast, we would use the neighbor command, and that's exactly what we're going to do. So on router 5, I'm going to say neighbor 10.3.5.3, which is the IP address of router 3. I'm going to say neighbor 10.3.5.5, and I'm going to give us some room here so that the next debug here is essentially the only thing that we want. Actually, it already happened already. Do on all. So take a look at what's going on here. Sending. So there's one send, one send. So we received 2 updates. Isn't this interesting? Check this out. So router 5 received 2 different updates from the same router. Sorry, let's say do on all. Router 5 received 2 different updates from the same router, almost at the same time. You can see there's, I mean, literally at the same time. And the reason is because if we go over to router 3 and we actually take a look at what router 3 sent, it sent 2 different updates. It sent one update to a multicast address, and it sent a second update to the neighbor address. Now, the thing is that in RIP, and look, it's the same IP address. So in case you're saying, no, it's the same interface, E00, and it's sending from the 10.3.5.3 interface. So the thing is that in RIP, the neighbor command does not disable multicast. The neighbor command in RIP only enables unicast. So in order to get router 3 and router 5 to talk only in unicast, we have to use the passive interface command. And be careful what you passive interface, and remember this because it can come back to bite you later on in your configuration. I'm going to do this on purpose to show you, mistakes that I myself have made. So let's go on router 5. We're going to say passive interface default. Let's say do debug IP RIP. Let's check router 3 to see when our next update is due in. Do show IP protocol. Seems like we may have already got it. Looks like we caught it just in time because we received only one update this time. Let's let this hang out for a second. Do debug IP RIP. Do show IP protocol. What do we have here? We got 15 seconds left. This isn't the end of the world. 9 seconds. We should see it coming out any minute now. And there we go. So router 3 only sent one update this time because he sent it to a unicast address. So that's exactly what we wanted. So as far as this is concerned, let me just check one more time. Do show IP route RIP. So we have router 5's 3 loopback addresses in our routing table. We're good. Now let's head over to router 6 here. Let's say show IP route. And let's see show run section IP route. Let's see if we have a static route here. We don't. Okay. We're going to need to create a static route on router 6 and router 2 in order to be able to get them to reach each other, which is not the end of the world. So we're going to say IP route 10.2.4.0. with a /24, and we're going to send the next hop to 10.4.6.4. Head over to 2, exit IP route. We're going to say 10. Come on, JP. .4.6.0/24 is going to go to 10.2.4.4. So let's say do ping 10.4.6.6, which of course is router 6, and we're good. So what we're going to do is let's now get a relationship going between router 6 and router 2. So we're going to say router RIP. We're going to say version 2, version 12. I hope I'm dead by then. Version 2, no auto. And I'm going to say neighbor, and we're going to say 10.2.4. Getting late. .2. Do show run section router RIP. And what happened? I don't see it. What happened? You know, I picture like this little baby right now, you know, just kind of sitting there like, it's only a RIP. I can't get it to work. Yeah, what happened? Even when you do something like this and you use the neighbor statement because you're planning on using unicast only, you still need a network statement. Do show run section router RIP. Without the network statement, RIP does not activate, even if you're going to go ahead and use the unicast neighbor command. Even though, yes, we are going to be sending multicast out of this interface, you know, we could go ahead and say passive interface default if we wanted to here. I'm not really going to worry about it because I made that point already. But, you know, even though we're using unicast to form a neighborship directly with router 2, you still need the network statement. So let's head over to 2. We're going to say router RIP. Let's say do show run section router RIP just to make sure. So that looks good. So we already have the network statement. So let's go ahead and say neighbor 10.4.6.6. Just make sure we can ping this guy just one more time. We're going to say source E01. Good. Do debug IP RIP. Go to 6. Do debug IP RIP. And it looks like we did get something already. And that's exactly what I wanted. Look, man, this is cranking today. I'm like right on time. So this says RIP. Look at this message we got right here. I'm highlighting it for you. Commit this to memory. Like do the RoboCop thing where you stick the knife in the little hole thingy and you twist it and you kind of do your little scan and you remember it. You guys probably have no idea what I'm talking about. But anyway, make sure that you remember this error, okay? Bad source, all right? What router 2 is telling us is saying, hey, I ignored this update because it came from a bad source. In other words, the subnet, the neighbor, the mask, the IP information that I'm getting from my neighbor is a bad source. We're not on the same subnet, okay? My interface is a 10.244/24 or 10.240/24. This guy's a 10.460/24. We're not even remotely the same. So this is not going to work. I'm not going to be able to accept any of these updates. And router 6 probably said the same thing somewhere in here. I hope somewhere. There we go. So router 6 goes ahead and says the same thing. Then this is a pretty easy problem to fix in RIP. If you're confined to fixing it in other ways, then you'll have to find ways in other technologies to fix them, okay? For example, if you had a dial-up network, if you were using, PPP, and you were doing, IP address negotiator, you were using, IP unnumbered, maybe you're doing a GRE tunnel, you would have to find ways to maybe get this interface to match, the /24, because by default, the way most people configure PPP when they're doing, when they're using DHCP or something like that, they're using, a negotiated IP address. I'm trying not to get into the details and get us way off track in case you're wondering why I'm beating around the bush. You're going to get a /32 mask here. You might still have the same exact IP, the same LAN segment, if you will. Might be 10.570/ whatever. This guy would have that /24. This guy is going to get a /32, and RIP is not going to work. So very easy to fix. You just have to make sure that you know where to fix it, right? So again, in RIP, easy problem to fix. If you're not allowed to do this in RIP, well, then you'll have to find another way to fix whatever the problem is in that particular technology in order to get around this. But the way we fix this is we simply say no valid, we hit the tab key, and the command is no validate update source. What you're doing here is you're telling RIP, I don't want you to check and make sure that we are on the same subnet. I want you to completely ignore the fact that this guy's coming from, all the way on the other side of our network. So we're going to say no valid, we're going to spell it right, and we're going to hit the tab key, and essentially we're done. Now if I go to router 2 and say do show IP route RIP, I'm going to have to wait for that update to come back in. Let's go to 6 and see when that is. Do show IP RIP, do show IP protocol rather. 4 seconds, so we should see it relatively quickly. We'll say do show IP route RIP. Route RIP. All right, that's it. I'm going to bed right after this video. Oh, I know what I forgot. Let's say do show run section RIP. Did I forget it? I did forget it. So redistribute connected. I forgot it. My bad. Do show IP RIP database, and there we have it. So there's our 3 loopback addresses coming in from router 6. Let's try to ping one of these guys just for kicks. Let's say ping 192.168.6.1, and we have reachability. So we didn't have to add any routes on router 4, so that's cool. So this works perfectly. So router 2 is able to get through router 4 to reach these loopback addresses of router 6, and he's getting these in via RIP. Now, let's examine something really quick. Do show IP route, and I'm going to say RIP. I'll try to make the rest of this video short, guys. I know you're probably falling asleep by now. So when we look at the routing table for RIP, a couple pieces of information we need to point out. All of our routes are always going to be RIP routes. We're never going to see, RIP external or RIP internal. RIP doesn't differentiate between route types like EIGRP would. You have D and you have DEX. D is internal. DEX stands for external. You don't have OSPF external type 1, external type 2s, NSSA type 1s, blah, 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 blah. They're just RIP routes. Administrative distance is 120. Very important number for you to remember. You guys have to remember things like OSPF is going to be 110, because if you have both routing protocols together, you have to know that if I have OSPF running in here and all of a sudden I take the OSPF routes and redistribute them, if I say redistribute connected in OSPF, all of a sudden that's going to take precedence, because if I say show IP route OSPF, I have OSPF routes running in here. So what if I come in and I make a mistake and I go into RIP on router 2 and I say redistribute connected into OSPF rather, all of a sudden, all of these routes are going to leave RIP because now they're in a protocol with a lower administrative distance, okay? And don't forget this metric, again, this metric value 1, the metric is the hop count, okay? So right now, RIP is telling, or RIP on router 2 is telling us that essentially I see these routes as being 1 hop away. Okay, now let's actually finish the very last piece of this and let's get this running over our DMVPN tunnel and we'll try to cap this off at 35 minutes. So we'll say router RIP, do show run section RIP. Now, I told you guys to be careful when you're doing passive interface default because it can come back to bite you. If you're not a verification Nazi like me and you don't come in and you don't say, hey, you know, I want to check to make sure everything that I do, you're gonna get bit right in the butt with this because you're gonna forget that you did this and you're gonna end up spending 10 minutes trying to figure out why RIP isn't running on your DMVPN tunnel because you forgot to say no passive, you know, tunnel 1, which is our tunnel interface. Okay. Now, if I say do show run interface tunnel 1, the subnet there is 172.16. So I'm gonna say network 172.16.0.0. We'll go over to router 3. Do show run. And I'm going to say section RIP, and we'll go into RIP, even though we're there already, but you know, you never know where you are. And I'm going to say no passive tunnel 1, and I'm going to say network 172.16.0.0. Do show run section RIP. Looks good. Let's get it running on router 1. So let's say show run interface. I don't even know what that is. Show run interface tunnel 1. Show run interface tunnel 1. All right, so there's our DMVPN tunnel. It's fully functional, so if I should be able to say from router 3, should be able to say, let's say do show DMVPN, and let's say do trace 172.116.1.2. Let's do it again. We should have a cast entry, do show DMVPN, and there we have our dynamic tunnel that's built, so we should have direct reachability to router 2 at this point, which we just tested. So now what we're going to do is I'm going to say router RIP version 2 no auto, and I'm going to say network 172.16.0.0 redistribute connected. Actually, I'm not going to do that. We'll leave that alone for now. And let's say show IP protocol. And you know what we'll do? We'll say config T router RIP passive interface default no passive tunnel 1. And let's say do show IP RIP database, and let's see what's happening. Look at that magic. So right now, we have all the loopback addresses that essentially we're concerned about. If we scroll down here, we see that we have the 192.168.4s obviously coming in from router 4 directly to router 2, and then being advertised to us over the tunnel. We should also see down here, we see the 6s. So we see router 6 advertising his loopback addresses over to 2, and then coming in over the tunnel. But let's go over to router 3, and let's actually see what router 3 has. So let's say show IP RIP database, and let's see what router 3 has. Router 3 only has the 3 loopback addresses from router 5. He doesn't have any of the information essentially that's being cooped up here over on router 1. Let's check router 2. If I say show IP RIP database, he's going to have all the information kicked over from router 4, kicked over from router 6, but he's not going to have any of the information from router 5 that would essentially be coming in over this spoke on router 3. And the reason is because of that split horizon rule, because router 1 is now blocking these routes from coming out in the other direction. Now, many of you here might be thinking route poisoning or poison reverse. I'm going to get into those in a totally separate video. Here, I'm not going to demo it. If you're aware of those features and you're there and you're studying, that's great. That's fantastic. Not going to demo that here. All we're going to do is fix this particular problem of split horizon. So what I'm going to do is say interface tunnel 1, and I'm going to say no IP split horizon. Now, if we were running EIGRP, this is the same command. If I hit the question mark here, you can see EIGRP, and then this is going to want my autonomous system number. But again, in RIP, I don't need to do that. I'm just going to say no IP split horizon, and almost automatically, almost instantly, if I say show IP RIP data, I should see, hopefully soon. Let's see when our next advertisement is over here on router 1. Let's say do show IP protocol. And let's see when it is. Looks like 1 second. So in theory, router 3 should have it by now. And there we go. So now router 3 knows about the loopback addresses to router 6, which means that we should see them. We still have the debug here working on router 5, so router 5 now sees them, and you can see that router 5 says, hey, you know, these guys are 4 hops away. Okay, so again, there's our metric value. So let's say show IP route RIP. So you can see the hop count here. We have a hop count of 3. Let's see on all. One more thing to show you after this, guys, and then you can go to bed. So here's our hop count of 4. Here we have the loopback address to the router 6. Let's actually see if we can ping them. 192.168.6.1. We're good to go. Let's actually see if we can source that from our loopback. Let's get really crazy. So our loopbacks on router 5 are able to jump to router 3, go through the DMVPN tunnel on 1, get over to 2, and then jump through router 4 and head over to 6. One last thing I do want to show you, which I did not mention, show IP route RIP, is that RIP will do equal cost load balancing. So right now we have router 3 and router 2 both connected, okay, both connected to the same 1024.35/24 subnet on that switch. And so because they're both advertising that subnet in over the DMVPN tunnel, router 5 sees 2 equal cost paths. When we say equal cost, what we mean is that metric value, that hop count, okay, which I'll show you how to tweak if you need to. But now we see that we have 2 equal cost paths to that subnet. So guys, I'm sorry for the maybe a little bit longer video than you would have hoped for RIP. You know, RIP is still very much involved, so I hope you guys enjoyed this video anyway, and I will see you guys in the next one.